Hello everyone. So today I'm going to be talking about the equation of ellipse. You can see that I have already pre-written off this because I accidentally deleted the previous video. Okay, so for just to review, for ellipse we have this thing, right? So negative a0, a0, because that's the major axis, and this is the minor axis, right? So this is foci 1 and this is foci 2, and this is negative c0 and c0 based on the definition, and this one we'll call it x comma y. This is 0 comma b because this is a minor axis, and this is 0 comma negative b. Okay, we'll talk about this later. Okay. So first of all, we want to prove the equation of ellipse today. So as I have said, we can start with PF1 or this line. So using distance formula, that's x minus this and then y minus this. So well, that we will get this, right? And PF2 using distance formula, that's x minus c and y minus 0, and that's PF2. So PF1 and PF2 added together is equal to 2a. That's based on the definition of ellipse. And so plug in 1 and 2 into 3, right? So this is what we will get. Well, interesting. So now we'll try to get rid of the annoying square roots, and the most efficient way is to move this over there. You can also like directly square root this, but that will be less efficient. So we moved it over there. Understand? That's yeah, okay. And then we square it. So this squared, then the square roots will be canceled out. This thing squared, then it will be this squared, which is this, plus minus 2ab, which is minus 2 times 2a times b. And there's a negative over there, yeah. Okay, cool. So, and then there's also the b squared, which is this thing. So that's awesome. Okay, so now x squared plus c squared plus 2cx plus y squared is equal to 4a squared plus x squared plus c squared minus 2cx plus y squared minus 4a square root of x minus c squared plus y squared. So I think that is pretty understandable, right? So here we expand into this. Y will keep it over here. This will be kept. This will be expanded into these three terms: a squared plus b squared minus 2ab. This will be kept, and this will be simplified. Okay, so now after expanding, this and this and this and this will be canceled out. And then so we can move the 2cx over there. So for AC we can move it over there. And then for this we can keep it over here. So that will give us, according to here, 4cx minus 4a squared and minus 4a square root of x minus c squared plus y squared. And now we divide by negative 4, so it's a squared minus c squared. You see we switch the order, and then that's equal to a square root of x minus c squared plus y squared. So we can square this one more time. So then a squared minus a minus b squared is a squared plus b squared minus c squared, right? Okay, so then that would be this squared, and then this squared, and then this is minus 2ab. Okay, and this will just be this thing. Oh, just found a mistake. Okay, so we can just expand this. We can just expand this, and then we'll find that we can cancel out the 2a squared cx term. So it'll be c squared x squared minus a squared x squared minus a squared y squared is equal to a squared c squared minus a to the 4. So that's, we just moved this over there, and then we kept this over here, and then for this term we move it over there. For this term we move it, and then for this term we just kept it over here. Okay, cool. So now from this we can have the x squared in common, then it'll be c squared and a squared, and minus a squared y squared, just keep that, and then this will be a squared in common, and then c squared minus a squared, and we multiply it by -1, so it's a squared minus c squared x squared plus a squared y squared is equal to a squared times a squared minus c squared. So divide by a squared minus c squared, then that'll be x squared plus this thing plus this, right? And since a squared minus c squared is equal to b squared, so x squared plus a squared y squared divided by b squared is equal to a squared. So finally divide by a squared, and then so we'll get this equation. So now we'll talk about the vertical one. So for the vertical one, we can see that like basically everything is the same, except you see now this, which used to be the x-axis, become the y-axis, and the old y will become the new x. So what we do is that we switch x and y. So that will give us the equation from here, we got here, and then so now that's for horizontal. So for the vertical, it would just be switching the x to y and y to x, and we just proved it. And thank you for watching.